Hi everyone, in this recording we will be solving the rational equation you see on your screen right now. The first thing we need to do is analyze our denominators and make sure everything is factored. X plus 1 we see twice in two denominators here, and then over here if we factor this denominator it actually is the product of x plus 1 and x plus 1. Now this example is a little silly if you ask me. I'm going to go about doing it if I were a robot, and then I'm going to also show you how you could handle this problem in a more efficient way. So when we solve a rational equation like this, the technique that we have been practicing is to multiply through the entire equation on both sides by the least common denominator. Now I could write the least common denominator in this example as x plus 1 times x plus 1, or as x plus 1 squared. In this example, if I multiply this by x plus 1 squared, an x plus 1 from the top will reduce with the only x plus 1 in the denominator, and I will just have 2x times 1 remaining x plus 1. The same idea will happen over here. 3x will have to be multiplied by an x plus 1, as the x plus 1 squared will reduce with this x plus 1 on bottom, which is technically to the first power, equals x squared. Well, x plus 1, they're both going to reduce, right? And in upcoming examples, I give different ways of showing this. So, you may benefit from some of the detail and props that I kind of throw into some of the examples further down in the playlist. And this is just x squared. Distribute, and we get 2x squared plus 2x plus 3x squared plus 3x equals x squared. 2x squared and 3x squared is 5x squared. 2x and 3x is 5x equals x squared. I'm going to subtract on over the x squared. That leaves me with 4x squared plus 5x equals 0. And we do want to get these equations equal to 0 before we start any of our factoring. So now from here, I don't know why I did that. I think I was looking at the 4 in my exponent. I have whiteout, sorry. I was looking at, the 4 is my, I see, and now I said exponent. I was looking at the 4 in my coefficient, and I accidentally put a 4 in my exponents. Why didn't you guys tell me? There we go. All right. So this example will require the factoring method of greatest common factor. What is the greatest common factor between 4x squared and 5x? That would be x. So if I'm going to undistribute it, I'm dividing it out. I also multiply it out here, keep some balance. And what does that bring us to? Well, an x out here and a 4x reduced that, right? You can't just cross out the x. Think about it. We've been doing this pretzel division since September, right? But suddenly we forget this when we're dealing with simplifying rational expressions, and you want to just cross these things out when there's a plus or a minus sign. You can't. It has to be able to reduce pretzel style from both if you're going to do that. You can't just cross one of them out, okay? 4x squared over x is just 4x, and then 5x over x is just 5 equals 0. And now we can use zero product property. I'm going to set x equal to 0. That one's already done. And 4x plus 5 equal to 0, which means 4x equals negative 5, which means x is equal to negative 5 fourths. So I have two answers if I go through solving this example in that technique. Now, if I go back to the original problem, what are my restrictions? Well, x can't equal 1. I'm sorry, not 1, negative 1. X can't equal negative 1 is my restriction. And are either of these answers 1? No. So we're good to go. This answer is fine, and this answer is fine. Nothing to worry about. Now, earlier I said that I was going to show you a different way to start this problem, right? If I wasn't being a robot. These two expressions right over here are they already have a common denominator, and the numerators are like terms. So really you could, without messing up, and I wonder if they do this on purpose, thinking like people are going to see that that's x plus 1, and they're going to think that they can add those, and the new denominator is x plus 1, but it's not, right? Like when you add common denominators, 7/3 plus 8/3 is 15/3. Like the denominator stays the same, right? So this, if you were to combine those two fractions right over there before anything started, you would just get 5x over, and of course it's not showing, 5x over x plus 1 right over here. And that would be equal to that right-hand side, which was x squared over, technically, x plus 1, or x plus 1 squared. So you could solve from here as well and get the same answer. I also imagine people may want to cross multiply here. I am not a big fan of cross multiplying because you guys try to use it everywhere and you also don't use it correctly. Just don't do it. Just avoid it. Just do this. It's better. Trust me, okay? So if you'd like to try to do it this way and see if you get the same answer we got the other way, I would definitely encourage that. All right. So that was just a little extra detail I wanted to share with you. I hope that you had done this example on your own first and were just checking it and feel good about it and did a good job. And for more practice, you can go ahead in the playlist and pick any other example you would like to check out. All right. Have a great day.